Students, whatever homework is given to you, you have to submit it on the very next day between 8 am to 1 pm to the given WhatsApp number, and it is compulsory to submit your homework as your attendance will be marked on the basis of your submission.
Good morning, students. Once again, I welcome you all in our online lecture. Okay, today we are going to start the part 2 of chapter 10, that is light, reflection and refraction. In today's lecture, we are going to learn about the ray diagram. That means how will you draw the ray diagram for lenses. That we are going to learn in our today's lecture. So let's start with our lecture. Okay, first of all we will learn about the rules which are necessary to keep in our mind before drawing any ray diagram. So first of all we go through the rules, okay, for drawing the ray diagram. Okay, so that is rule number 1. We will start with rule number 1. So what is the rule number 1? As per rule number 1, whenever the ray of light, incident ray, is parallel to principal axis, this is your principal axis, this is known as your principal axis, okay, and this is your optical center O. A straight horizontal line passing through the optical center and focus of the lenses is known as principal axis. So this is your f1, this is your 2f1, this is your f2, and this is your 2f2. In lenses on either side we are having two focus. This is focus 1, focus 2, this is focus 1 and focus 2. This is f1, 2f1, f2 and 2f2, and whatever the distance is there between O to f1, f1 to 2f1, O to f2, f2 to 2f2, all the distance are equal to one another. That means distance of O to f1 and O to f2 is equal. Distance of f1 to 2f1 and f2 to 2f2, all distance are equal to one another. Okay, so rule number 1 is whenever your incident ray is parallel to principal axis. Okay, this is your incident ray. This is your incident ray. So as per rule number 1, whenever the incident ray is parallel to principal axis, this is your principal axis. So if your incident ray is parallel to principal axis, so after refraction it will pass through the focus on the other side of the lenses. Okay, it will pass through the focus on the other side of the lenses. So लेंस के दूसरी तरफ कौन सा फोकस है? f2. सो अगर आपकी इंसिडेंट रे यहाँ से आ रही है एंड इट इज पैरेलल टू प्रिंसिपल एक्सिस, सो यहाँ ऑप्टिकल सेंटर की जो स्ट्रेट लाइन है वहां उसका रिफ्रैक्शन होगा, एंड आफ्टर रिफ्रैक्शन दैट रे विल पास थ्रू फोकस f2 व्हिच इज ऑन द अदर साइड ऑफ द लेंस. So that is rule number 1. Similarly we can draw the line in the lower part also. Suppose मैंने यहाँ line draw की. So suppose this is your incident ray which is parallel to principal axis. So after reflection it will pass through this way like this. Okay, done. So if your incident ray is parallel to principal axis, after refraction it will pass through f2. Similarly if your incident ray is here parallel to principal axis, it will again pass through f2. So in general, whenever your incident ray is parallel to principal axis, after refraction it will pass through principal focus on the other side of the lens, because see we are also having focus on this side which is in the front of the mirror, but after refraction incident ray will pass through focus which is on the other side of the lens. Okay, is it clear? Okay, now rule number 2. Now the same thing will happen in concave lens. Okay, this is your convex lens, this was your convex lens. Now we will learn the same thing for concave lens. So what happened in concave lens? Again, this is your optical center, this is your f1, this is your 2f1, this is your f2, and this is your 2f2. Now if your incident ray is parallel like this to principal axis. Your incident ray is parallel to principal axis. Okay, this is your incident ray. So as we know, in concave lens, your ray will get diverged. Your ray will get diverged. So after refraction, okay, it will pass through like this. It will pass through like this. Means after refraction, your light ray will go in this direction. But you have to extend it in a such a way that it look like passing through the focus, which is in the front of the mirror. So here, so this is the case. In case of concave lens, if your principal axis, if your incident ray is parallel to principal axis, after refraction it will go on the other side of the mirror. But if you extend it backwards, it will look like passing through the principal focus, which is in the front of the lens. Whereas in the convex lens, it will pass through the focus, which is on the other side of the lens. So that is the difference. Okay. Now rule number 2. Let's take rule number 2. So what happened in rule number 2? If now this is your optical center O, this is your F1, this is your 2F1, this is your F2, and this is your 2F2. Now as per rule number 2, okay, if your incident ray is passing through principal axis, like this, this is your incident ray. Your incident ray is passing through the focus. So after refraction, it will become parallel. To principal axis. So as per rule number 2, if your incident ray is passing through principal focus, that is F1, after refraction at optical center, it will become parallel to principal axis. यानी अगर आपकी इंसिडेंट रे फोकस से पास हो रही है, तो रिफ्लेक्शन होने के बाद वो प्रिंसिपल एक्सिस को पैरेलल हो जाएगी. सो दैट इज द रूल नंबर 2. नाउ लेट्स सी सेम रूल फॉर कॉन्केव लेंस. ठीक है, नाउ वी विल सी इट फॉर कॉन्केव लेंस. ठीक है, सो फॉर कॉन्केव लेंस, again this is your optical center, this is your focus F1, this is your focus 2F1, this is your focus F2, and this is your focus 2F2. So in case of convex lens, ठीक है, you have to just show that your incident ray is passing through the focus, because it is not actually passing, because in case of concave lens we have to just show that it is passing through the focus like this. ठीक है, देखो मैंने फोकस से टैली कर दिया है. So we have to show that our incident ray is passing through the focus. ठीक है, so here the refraction will take place. So see, if we extend that incident ray, this is your incident ray. If we extend that incident ray, it will looks like passing through the focus. So after reflection at optical center, it will become parallel. To principal axis. So this is the case for concave lens. So what was the rule number 1? Rule number 1 में हमने क्या पढ़ा? If your incident ray is parallel to principal axis, so after refraction it will pass through the focus. And rule number 2, if your incident ray is passing through the focus, after refraction it will become parallel to principal axis. Clear? Okay, now let's see the rule number 3. ठीक है, now हम rule number 3 देखेंगे. So what is rule number 3? So as per rule number 3, again this is your convex lens and this is your concave lens. ठीक है, this is your optical center O, this is F1, this is 2F1, this is F2, this is 2F2. Again it's optical center, this is F1, this is 2F1, this is F2, this is 2F2. So as per rule number 3, if your incident ray is passing through optical center, so after refraction, ठीक है, it will go through the optical center, यानी वो वापस आएगी नहीं. ठीक है, so this is your incident ray. So if your incident ray is passing through optical center, so it will move forward in the same direction. It is not going to change its direction. and so as in concave lens also. Similar thing will happen in concave lens also. Your incident ray is passing through the optical center, so it will be in the same direction. It will go in the same direction. It is not going to change its direction. So this is your incident ray. So these are the 3 rules for drawing the ray diagram for lenses. Okay, so let's summarize the rules again. So this was your rule number 1. If your incident ray is parallel to principal axis, so it will pass through principal focus on the other side of the lens in case of convex lens. For concave lens, if your incident ray is parallel, so it will get refracted in the other direction. But if we extend that direction in the backward, if we extend that refracted ray in the backward side, we will see that it is passing through the principal focus. Rule number 2, if your incident ray is passing through principal focus f1, so after refraction it will become parallel to principal axis. That is for convex lens. In case of concave lens, you have to just draw the incident ray in such a way that is directed towards the principal focus f2. So after refraction it will become parallel to principal axis. Then ray diagram number 3, rule number 3. If your incident ray is passing through optical center, so it will move further in the same direction. It is not going to change its direction in convex as well as in concave lens. Okay students, so that's all about the rules of drawing the ray diagram for lenses. Okay students, now we will move forward towards the ray diagram for convex lens. Total there are 6 ray diagrams for convex lens. We are going to draw them one by one. Let's take the first situation. Suppose my object is at infinity. My object is at infinity. Now you have to keep one thing in your mind always, that object is always placed on the left hand side. This is your lens. So this is your left side and this is your right side. Okay, so object is always on the left side. ऑब्जेक्ट को हमेशा लेफ्ट साइड ही रखा जाता है, यानी जो भी इंसिडेंट रे है वो हमेशा लेफ्ट साइड से आएगी. तो ये चीज आपके दिमाग में क्लियर होनी चाहिए कि ऑब्जेक्ट हमेशा लेफ्ट साइड होता है तो उसकी इंसिडेंट रे लेफ्ट साइड से आएगी. एंड ऑल दोस इंसिडेंट रे आर ऑलवेज पैरेलल टू प्रिंसिपल एक्सिस. वो सारी इंसिडेंट रे हमेशा प्रिंसिपल एक्सिस को पैरेलल होती है. ओके, सो सपोज मेरा ऑब्जेक्ट इन्फिनिटी है. अब इन्फिनिटी की पोजीशन हम फिक्स नहीं कर सकते, हम खाली एज्यूम करेंगे कि वहां से जो रेस आ रही है वो पैरेलल है. Whatever the rays are coming from the objects are parallel to principal axis. ठीक है, तो ऐसे मैं 2 रे ड्रॉ कर रहा हूं, एक प्रिंसिपल एक्सिस के ऊपर और एक प्रिंसिपल एक्सिस के नीचे. So these 2 are my incident ray which are coming from the object which is at infinity, and both this incident ray are parallel to principal axis. Both this incident ray are parallel to principal axis. Now this is our optical center O, this is f1, this is 2f1, this is f2 and this is 2f2. So as per rule number 1, what we have learned, if my incident ray are parallel to principal axis, so after refraction they will pass through principal focus. So I am passing this ray from principal focus. See, similarly for this incident ray, this is also parallel to principal axis, so after reflection it will pass through principal focus. Okay, so this is the case. Incident ray parallel to principal axis, after reflection they are meeting each other at f2. So my image will be at f2. My image will be formed at f2. Now see, whatever the image formed by convex lens is real and inverted. Image formed by convex lens is real and inverted. Now see, real, why I have written this word real for the image? Because both the incident ray after reflection are meeting at one point only. On their own they are meeting each other at one point. I am not making them meet at that point. They are actually meeting on their own at that point. So when all the incident ray after reflection meet at one point on their own, then such image is known as real. And for real we are writing inverted. Why I am writing this inverted, that I will explain in the next diagram. For now you just remember real and inverted. Real, why real? Because both the incident ray are meeting at f2 on their own, that's why. And size, you can see object is very big, because at infinity naturally my object will be very big, but I am getting the image at point f2. So f2 is a point which is very small, so my size of the image is highly diminished. Size of the image will be highly diminished, or you can say point like, okay. So this is the first ray diagram for the convex lens. If your object is at infinity, your image will be at f2, its nature is going to be real and inverted, and size is going to be highly diminished. Okay, now let's draw the next diagram. Okay, that is second diagram. That is, my object is at focus. Focus means f1. Okay, so this is your f1, this is your 2f1, this is your f2, and this is your 2f2. When my object is at f1 and focus पे है मेरा diagram object. So this is my object. I am drawing the arrow for the object. So this is my object, and object is, the name of the object is AB. A is the upper point of the object and B is the lower point of the object. Now as per rule, first my इंसिडेंट रे विल बी पैरेलल टू प्रिंसिपल एक्सिस. ठीक है, तो ये मैंने इंसिडेंट रे पैरेलल ड्रॉ की. सो आफ्टर रिफ्रैक्शन इट विल पास थ्रू प्रिंसिपल फोकस लाइक दिस. सो इट इज पासिंग थ्रू द प्रिंसिपल फोकस. ओके, हम क्या करेंगे, जो भी ऑब्जेक्ट ड्रॉ किया उससे पहले एक इंसिडेंट रे पैरेलल ड्रॉ करेंगे प्रिंसिपल एक्सिस को, जो रिफ्रैक्शन होने के बाद फोकस से पास होगी f2 से. अब हम एक रे ऑप्टिकल सेंटर से पास करेंगे. कहां से पास करेंगे, optical center. So as per rule, a line passing through optical center will move forward in the same direction. So you can see both these rays are not going to meet each other, just like in this case. यहाँ क्या था, दोनों रे प्रिंसिपल फोकस पे मिल गई थी, लेकिन in this case both this incident ray are not going to meet each other after refraction. That means my object image will be formed at infinity. मेरा जो भी इमेज है वो कहाँ मिलेगा, infinity पे. नेचर की बात करें तो अगेन इट्स रियल एंड इन्वर्टेड. जो भी इमेज होगा वो रियल एंड इन्वर्टेड होगा. ओके, एंड द साइज इज गोइंग टू बी हाईली एनलार्ज्ड. माय साइज इज गोइंग टू बी हाईली एनलार्ज्ड. Okay, so this is the second diagram for convex lens. My object is at focus, image is at infinity, nature of the image is real and inverted, size of the image is highly enlarged because the object is going to form at infinity, so obviously its size is going to be bigger than the object, so its size of the image is highly enlarged. Okay, so that's all for this today's lecture, dear students. In today's lecture, what we have learned, we learn about the rules. We learn about the rules to remember during ray diagram, during drawing the ray diagram. Okay. Apart from that, we have also learned how the image formation take place in terms of convex lens. In that, we learn two diagram. First for object at infinity, and the second diagram for the object at focus. Now see, if your object is at infinity, your image is at focus, and when your object is at focus, your image is at infinity. Well, that is the difference. So that's all for today's lecture. We will continue our remaining ray diagram in the part 3 of this lecture of this chapter. Till then, take care. Bye bye.